All right, we're beginning Unit 2 today, and in this video, we're going to be focusing on reviewing pretty much everything you've ever covered about linear equations. We're going to be graphing linear equations in various forms, as well as writing equations of lines, okay? So let's get right into the review. We know that slope is a concept specific to lines. It's a measure of how the change in the y-coordinates compare to the change in x-coordinates from point to point. Slope is often designated in mathematics with the letter m, and we have a formula to find the slope between 2 points on a line, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That would, of course, be if points x1, y1, and x2, y2 are points on the line, okay? Recall that the slope of a horizontal line is always 0, and horizontal lines are going to have the equation y equals a constant, a, right? So like y equals 3 would be considered a horizontal line when graphed, okay? The slope of a vertical line is considered to be undefined, and its equation will always be x equals a constant. So something like x equals 4 is an example of a vertical line. Recall parallel lines, they have equal slopes, and perpendicular lines, they have slopes that are opposite reciprocals. Okay, so what I mean by that is, let's say one line has a slope of 2/3, then a line perpendicular to it, it would have to have a slope of -3/2. Okay? All right, moving forward, there are 3 different forms of a linear equation. So let's review each of those. The first is slope-intercept form. It's going to follow the form y equals mx plus b, where m is the slope of the line and b is the y-intercept, right? Then we have point slope form for a line. Y minus y sub 1 equals m times the quantity x minus x sub 1. And the reason this is called point slope form is because the coordinates or the values of x sub 1 and y sub 1, they come together to give you 1 point on the line. And then m is, of course, your slope for the line. Finally, we have the standard or general form of a line, depending on what textbook you're looking at. Sometimes it's referred to as standard, others it's referred to as general. It looks like this: ax plus by equals c, where a, b, and c are all integers, meaning no fractions, no decimals. A has to be greater than 0, meaning a can't be negative, and a and b both cannot equal 0, okay? All right, so let's now get into some examples. Here we are given 3 linear equations, one in each form, and we need to graph the equation without changing its form, okay? Let's start with the equation in red there. That is in standard or general form. Anytime my equation is in that form, I'm going to graph it by finding the x and the y intercepts. Okay. All right, now x and y intercepts are pretty simple to find in this form. If I want an x-intercept, I simply plug 0 in for y. That's going to nullify the -6 here. Solve for x, I'll end up with x equals 6, which corresponds to the point of 6, 0 on this line. Go ahead and plot that point. If I want the y-intercept, I'll plug in 0 for x in the equation. That's going to nullify the 2. Solving for y, 12 divided by -6 gives me a y value of -2. So this is the point 0, -2. Go ahead and plot it. And 2 points is all you need to make a line. I could find some more points on the line if I recognize that the slope from the 2 points I have plotted so far, it's up 2 and right 6, which 2 over 6 reduces to 1/3. So I could use that to get some more points in there and connect them all to make my line. Okay. Let's next do the equation in blue. That's in slope-intercept form. Just by looking at that, I can tell the slope of the line is 2/3, and I can tell the y-intercept is -4, right? So I plot the y-intercept, use the slope to find more points. I'm either going to rise up 2 and run 3 to the right, or I'm going to go down 2 and I'm going to go left 3. There is my line. All right, finally we have point slope form. And for whatever reason, students always want to try to convert point slope form into slope intercept form before they graph it. It is not necessary, okay? Just by looking at this equation in green, I can tell you that the point -4, +3 is on the line. So I am going to plot that point. And then I can also tell you that the slope of this line is 1/3. So from this point, I'm going to rise up 1 and I'm going to run 3. Do that a few times. Or I could have gone down 1 and left 3. And there we go. All right, now one other interesting thing to note here after we have all these graphed is look at green and red lines there. Those are parallel lines. They have the same slope. Okay. All right, moving forward. Now let's look at how we can write the equation of a line, all right, based on some given information. So we'd like to write an equation for a line that passes through 2, -2 and is perpendicular to 2x minus 3y equals 4. So we know the point that we want our new line to have. We don't know anything else directly about it other than it's supposed to be perpendicular to this equation that's given. So if we find the slope of that equation, we can use the fact that perpendicular lines have slopes that are opposite reciprocals to help us determine our new line's slope and then give us the equation. So the first thing I'm going to do is try to find the slope of this line. Several different ways I can do it, but probably the easiest is to go to slope-intercept form. So I'm going to solve it for y. So I subtract 2x over, I'll then divide by -3, and I'll end up with y equals 2/3 x minus 4/3. Now the only thing I care about in that result is that the slope is 2/3. Okay, that means my perpendicular line, the line that I'm going to try to make an equation for, has to have a slope of -3/2. Okay, so now that I know my slope and I know a point that my line is supposed to go through, I can now write an equation in point slope form for this line. It will be y plus 2 is equal to -3/2 times x, the quantity of x minus 2. So that was using the coordinates of this point as well as this slope. Okay. Now, point slope form is fantastic, but a lot of times we want the final equation to be placed in slope intercept form. So I'm going to solve this for y by distributing here. Then subtracting 2 over. And here we have it. All right, moving forward, let's apply this process in a different scenario, okay? So last chapter, or last unit, we introduced to you the concept of an average rate of change, okay? And really we saw that average rate of change, it's a lot like slope, but it pertains to equations that aren't linear, okay? The average rate of change can be thought of as the slope of a secant line that passes through points A and B on any given curve, okay? So notice in my graph here, I have in blue the graph of a parabola, okay? This is a quadratic equation that's been graphed, all right? There is no constant slope in a quadratic equation, okay? What I'd like to do is find the equation for the secant line that goes through the points on this parabola whose x-coordinates are -2 and +1. Okay, so I'm trying to find essentially the average rate of change of this curve from x values of -2 to +1. That's like the slope of this secant line that you see in red here. And once I have that slope, I can then come up with an equation to represent that line. Okay. Let me back up here. Understand why it's called a secant line. If you think back to your geometry courses, you probably looked at secant lines of circles, right? So here's your circle, and then a secant line would be, a line that intersects the circle at any 2 points, okay? So that's very similar to what we have going on here. We have this line intersecting the parabola at 2 random points, therefore called a secant line, okay? All right, so first thing we're going to need to do, notice we have the equation for the function or the parabola here, f of x equals 3x squared minus 2x plus 3. We're going to need to evaluate that at the two x values that we are drawing the secant line through. So let's find f of -2 as well as f of 1. Now I'm going to cheat here since I have the graph already in front of me. It looks like f of -2 should result in 19 for my y value. So I'm noticing the secant line is passing through the point -2, 19. And then f of 1 should be 4. The secant line is also passing through 1, 4. If you didn't have the graph in front of you, you would actually have to plug -2 and 1 in for x into the function, simplify to get your y's. So now I find that average rate of change between these 2 points. Again, essentially just like using your slope formula. All right, so that's going to turn out to be 15 over -3, which of course reduces to -5, right? Now that I have that average rate of change or that slope, I can make an equation for this line in point slope form. I'm going to pick the point 1, 4, and use the slope of -5 to make this in point slope form. And then I'll go to slope intercept form. Okay, there's the equation, and compare it to the line that's been graphed there. Y-intercept of 9, slope of -5 does appear to match.